Hey guys, Oric here. I'm going to go through the Chapter 6 practice test. Here is how you work these linear regression problems. So here is the practice test, blank copy, and pretty similar type problem will be on the regular test. So what we need to do is a lot of this gets done on the calculator. So what we're going to do is we're going to put the first list into list 1 on the calculator and the second column into list 2 on the calculator, and that will then we can get all our linear regression line and our correlation coefficient all from a couple of buttons on the calculator. We could even do a scatter plot if we wanted to. So here is, I'll do that first. I'll put the list in the calculator. Here is my calculator. And I hit stat. Oh, I got to turn it on. I hit stat and then just enter, or stat and edit. Now if you have a list in here like I do, you arrow up to so the list is highlighted, hit clear, and then I just arrow down and that will clear it. Or on this one, I'll arrow up, highlight the list, hit clear, and then you can hit the enter key. That will clear it as well. And so here's my list 1, 1980, so it's year. I'm going to show you one other thing on the calculator, why my numbers are showing up the way they are. If you click on mode, instead of floating decimal point, I have the decimals rounded off to 3 decimal points. So my year will show up as a decimal point and have decimals after it, but it's kind of nice for a correlation, so I don't have a real long decimal, and I'll just set it to 3. But you don't have to do that, just if you're wondering why that looks the way it does. So once again, stat, enter. I have 1980 in there. 1984, 1986, 1990, 1993, and 1995. And then in list 2, I put these dollar amounts, 17,522, 19,049, 23,613, 26,395, 28,307. And these 2 lists need to be the same length for the linear regression to work. And just to show you quick how that you could plot this on a scatter plot, is you hit second, stat plot, you turn the graph on, and the second type there is the scatter plot. And list 1 and list 2. I want to make sure my y equals is empty, which it is. And then zoom, and the number 9 will be a graph with the right window. And there's my scatter plot. I can hit trace and then go from point to point. 1986 is 19,049, as you can see over here. And now to get the answers to the questions on the practice test here, let me minimize that for a second. First of all, what's the explanatory variable? Well, the year is the explanatory variable, and my annual compensation, I'll just put $sign just to abbreviate since I'm writing with my mouse. But your annual compensation is the response variable. So in the whatever year it is, it's going to determine what our annual compensation is. Now to find that linear regression line, I put the 2 lists in, and then I hit stat, arrow 1 over to calculate, and then number 4, linear regression. So I'll hit number 4. It's going to default to list 1 and list 2. Hit enter. And here is my line. Y equals 933.7. That's my A right here. X plus B, which is negative 1,834,598. And you might wonder why that's such a strange number. So let me put this in here. Y equals negative, was it negative? No, 933.7 y equals 933.7 minus 1,834,598. 834,598. So rounded to one decimal place, what's the slope? The slope is no, sorry, there should be an x right here. 933.7x. So our slope is 933.7. And once again, that's on my calculator, that's A. And B is my y-intercept, negative 1,834,598. And this gives us a really good example of why linear regression doesn't always work outside the scope of our data. So we started our data in the year 1980, and we're using the number 1,980. So if we were to graph this on our x-axis, we're out at 1,980. And we went through 1995. Now it might be able to predict what the wages are going to be in the year 2000, and it'll be really good to estimate what the annual compensation is in 1987 or 1988 within the range of this data. But at year 0, that's what the y-intercept is. That's where x is equal to 0. So that'd be year 0, which of course doesn't make much sense when we're talking about wages. What does the slope represent? Our slope is 933. So every year we go up 1 year, our annual compensation went up $933.7. So close to $1,000 a year annual increase. What does the slope represent? So once again, each 1 year increase, 1 year increase, I'll put an up arrow, wages increased by, it's really hard to write with this mouse here, wages increased by $933. Use your equation to estimate what the compensation was in 1992 and 2010. So what you do is you put this into your equation here. Right here, you into this equation, 933.7 times 1,992 minus 1,834,598. Now I'm going to cheat just a little bit, and this is kind of neat, so I'll show you how to do it on the calculator. When I did my linear regression test and a number 4, I use list 1, list 2, and I'm going to store my regression equation into the variable, into the y variable in the y function. I'll show you what that means. I'm going to store the equation in there. So it gives me the same answer, and now I look at y equals, and now I have that equation in my y equals. So I can just hit second and table. I don't like it when it does this. I can go into my table here and plug in an x, and it'll give me a y. So here's 1992, and trying to move my, there we go, 1992 and 2010. So there's my two wages, 25,339. 25,339, and in 2010 it was 42,146. 42,146. Well, I meant to get rid of this line because I just did that. No, I already printed the practice test, so that is what it is. R on my calculator, once again, stat calc number 4. And when I had it up, I should have wrote it down. It's 0.996. 0.996. That is, you know, very, very close to 1. So that's almost a perfect linear relationship between the year and the annual compensation. And it's positive. In other words, it's positive as years increase, wages increase. Now, I'm not going to write in all the answers on this next part of the test. I'll put an answer key online, but we'll go through this just so you can see once again how to do it. So I'll put the 2 equations or the 2 lists into my calculator. So click on stat, and then enter for editing the lists. Clear the lists out from my last problem. Hit clear. And we're doing weight and MPG, miles per gallon. And list 2. So in other words, the higher the weight of the vehicle, the less the gas mileage is. And so there's my 2 lists. Find your linear regression equation. And so you click on stat, calculate, linear regression. And you can just hit enter all the way through it. I'm going to do that again just to give you the answers for my estimate. So it's variable, y variable. I'll put the equation into this y equals right here. Stat calc number 4. And here's my A, negative 0.01, negative 0.01x. So y equals, here's my line, y equals negative 0.01x plus 58.9. Plus 58.9. And in my y equals, I have a little bit more decimal points out. What does the slope represent? Well, basically every 1 pound increase, our gas mileage goes down by 0.01. Use the equation to estimate our miles per gallon for 2,000 and 5,000 pounds. So if I hit second table, I do 2,000 since I changed this, and 5,000. So a 2,000 pound vehicle, and if you look over here on the chart, 1,900 got 42 miles per gallon, 2,400 pounds got 34. We're at 38.9 for 2,000. So it fits in. 5,000, we're down to about 8.9. Now at some point this is not going to make any sense because at a certain weight vehicle we're going to be getting negative miles per gallon because the slope's going down. But within the scope of this data, this is pretty accurate. So it's 8.9 and 38.9. 38.9 miles per gallon. Direction of the relationship, this is a negative. As the weight increases, the miles per gallon decreases. And I forgot to write down the correlation coefficient, which is R, negative 0.975. Negative 0.975. Very strong negative relationship. Once you get up to above 0.8, that's a strong relationship, whether it's positive or negative. And notice one other thing, the slope. If the slope is negative, your R value is going to be negative. Slope is positive, your R value is going to be positive. What values can, they're talking about R. What values can R be? It can be anywhere between -1 and it can equal -1. That's a perfectly straight line. I should put R, not X. R, and it has to be less than 1. You can't have a R value of 1.1 or 2 or 3, and you can't have an R value less than a -1. The slope and the R value will have the same sign. So if R is negative, a negative correlation, the slope will be negative. In other words, the line will be going down. So same sign. All right, here's a short list. Just by looking at this data, and this is a question on the test, you can see size of the house, 1,200, heating costs 50. You almost double the size of the house and the heating cost about doubles. 1,800 goes to 90, 2,000, it goes up a little bit more. So you can tell that the bigger the house, the higher the heating cost. And it looks like it's a pretty strong correlation. On the test, it's a multiple choice question. So here's your R value. Smaller, so that means larger houses cost more to heat. Larger houses cost more to heat. So it's got to be either B or C. And it's very strong, so it's almost perfectly straight. So answer is B. So find R. So here's our two lists of numbers. We're looking at their GPA and how it relates to their SAT scores. Stat. Calculate number 4. Oh, I gotta first put the list in there. Stat, edit. Clear the list. Don't hit delete. That'll get rid of the list altogether. Clear. And we got 3.1, 3.4, 3.7, 3.2. Some good grade point averages here. And 650, 680, 770, 710, and 730. And we want to find R. Stat, calculate, number 4. Enter, 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 enter. R is 0.826. Once again, on the test, that's going to be a multiple choice. 0.826. If we want to estimate based on our linear regression line that's right here, we'd have 137x 137.0 plus 239. So you can store the line like I did and look it up in the table, but the other way, just do it on your calculator and do 137 times x, so we're wondering about 3.8 GPA times 3.8 plus 239.4. That was our B. Y equals mx plus b, so m was 137 times x, which we're trying it out for 3.8, plus 239.4 equals 760, right on the nose, which is strange considering I rounded it. Here's a scatter plot. Here is our, that's a bad line. Let me put a line in here. So there's going to be a line that's something like that would fit it. Estimate the correlation. It's positive, so it's got to be a positive number. So if you have some multiple choice answers fairly close to the line, when you get down around like 0.3, 0.4, 0.5, the dots are much more spread out. So this is going to be a plus somewhere probably between 0.7 to somewhere between plus 0.7 to 0.9. And there's not going to be two multiple choice answers that are within that range. I would guess it's about 0.8. Which correlation indicates strong positive straight line relationship? Oh, that's when I took the multiple choice answers. Strong positive, it's got to be an R that's positive number and close to 1. So R equals 1 or anything anything greater than or equal to, well, I shouldn't say equal, anything around 0.7 or higher, definitely 0.8 or higher. So 0.7, you're a pretty strong relationship. Once you get up to 0.8, 0.9, you have a really strong relationship. And then R equals 1 is a perfectly straight line relationship. In a scatter plot, it's form, direction, and strength. Form is linear, direction is either positive or negative, and then our R value close to 1 is strong, close to 0 is weak. And the last couple questions are really just plugging in x. So when x equals a -10, that would be -10 times -20. That's going to be positive 200 plus 500, so y will equal 700. So just plug in -10 for x. Just be careful with your negatives there. Y equals -20 times -10. So that's positive 200 plus 500. So that's 200 plus 500, 700. Same thing on this one, 0.5 times 68 plus 35. And 0.5 times 68 is 34 plus 35 is equal to 69. And 10%, we're going to put 0.1 in for x. So you go -0.43 times 0.1 plus 0.08. And once again, these are multiple choice. So if you weren't sure, try 10 for 10%, or try 0.1 and you should get the right answer. So -0.43 is, it's going to end up being 0.08 minus 0.043. What is that? 0.37? 0.037. And that should take care of it. It should be a fairly smooth test. There's 2 of those problems where you have to enter your lists in and find R and find your equation. And then most of the time, then it's just predicting values when you plug in an x into your linear equation. All right, good luck on the test. Ask me any questions in class. Thank you. Bye.